Hello everyone, this is Ryumyak, a first year master student at Nagoya University in Japan. The title of my presentation is Fuzz4B, a front end to AFL, not only for fuzzing experts. First of all, I'd like to talk about fuzzing. Fuzzing is one of the automated software testing techniques. We code tools that automatically execute it further. This figure shows a process it repeats to detect failure. Firstly, it generates the input data. The generated data is called fuzz. Secondly, it sends the fuzz to the target software system. Thirdly, it monitors the response of the software system. It detects failures by repeating this process. Next, I talk about AFL. AFL is one of the represented fuzzers that has a successful track record. This figure shows its overview. The user input of AFL are target program compiled for AFL and initial sheets AFL uses as first test cases. The output of AFL are fuzzies that cause a crash, fuzzies in the cube shown on this slide, and so on. When a user invokes AFL, it saves initial sheets in the queue. After that, it repeats the process shown on this slide. Firstly, it gets a new fuzz by mutating one of the fuzzes in the queue. Mutate means editing a fuzz by adding constant value, inverting bits, and so on. Secondly, it executes the target program which feeds in the generated fuzz. Thirdly, if it detects a new path by this execution, it saves the fuzz in the queue. It repeats this process until the user stops AFL. It is a CUI-based tool and invoked by this AFL fuzz command. This figure shows its interface during fuzzing. It shows the user the number of detected classes, paths, and so on. Now, let's move on to talking about the hindrances to novices using AFL. This figure shows a flow where a user fixes failures by using AFL. The flow comprises 5 steps. Firstly, the user invokes AFL and starts fuzzing. If AFL detects some failures, the user reproduces failures and then investigates the cause of them. If the user can identify the cause, the user fixes the source code and then starts fuzzing again. The user repeats this process until AFL is unable to detect a failure. However, we believe that there are some hindrances in this flow. Gray rectangles are steps we regard as hindrances. Firstly, I talk about the step invoke AFL. To invoke AFL, users need to compile the target program for AFL with AFL compiler, prepare chassis, and set the parameters correctly to the AFL fuzz command. We believe that it's so difficult for novices to understand these requirements. As a result, they spend less time. Next, I talk about the steps, reproduce the crash, and investigate the cause. This figure shows the output directory of AFL. We believe that it's difficult for novices to understand the detail of this directory. As a result, it's hard for novices to reproduce failures and make the output for debugging. To address these hindrances, we developed a tool named Fuzz4B. I talk about the overview of Fuzz4B. We suppose that the users of Fuzz4B are developers with basic computer science education. They are familiar with programming, have basic knowledge about software engineering, know simple Linux GUI and debug operation, and are familiar with AFL. Fuzz4B has three features: AFL GUI, repro crash, and DD. AFL GUI is the front end to AFL. Repro crash enables the user to reproduce failures detected by AFL. DD reduces the size of a fuzz that causes a failure. Now, I talk about the more detail of repro crash and DD. Firstly, I talk about the detail of repro crash. This figure shows its overview. As I mentioned before, it's hard for novices to reproduce failures and make some output for debugging. To address this hindrance, we implemented repro crash. This feature allows the user to invoke GDB and feed the fuzz to the target program by selecting a fuzz. The user can select not only fuzzes that cause failures, but also fuzzes in the queue of AFL and fuzzes reduced by DD. So, the user can reproduce failures and make use of output for debugging by only selecting a fuzz. Next, I talk about the detail of DD. This figure shows an example of the use of it. In this example, a user is testing a calculator by AFL. This calculator crashes when the input data includes zero division. AFL sometimes generates so long and executable fuzzes. In this example, AFL generates the long fuzz shown on the left-hand side. This fuzz includes zero division, but the user cannot find it because of the size of the fuzz. This makes it hard for users to identify the cause of failures. To address this hindrance, we implemented DD. This feature allows the user to reduce the size of fuzzes by delta debugging. The long fuzz shown on the left-hand side is reduced to the fuzz that consists of only zero division by this feature. Like this, Fuzz4B makes it easier for users to guess the cause of failures. I'll explain delta debugging. The user input of delta debugging are a target program and an input data. The target program includes failures. The input data, namely a fuzz, causes the target program a failure. Suppose n is granularity. It firstly divides the fuzz into n based on the size of the fuzz and generates n data. Here, n's initial value is 2. Next, it executes the target program with the generated data, and then monitors whether a failure is caused. If a failure is not caused, it doubles n, and then divides the fuzz into n again, and then executes monitors target program again. If a failure is caused, it subtracts 1 from n. In delta debugging, it repeats this process. Finally, it gels the reduced fuzz that also causes a failure. Now, let's move on to talking about the demonstration of Fuzz4B. In the demonstration, we use the open source software librope as target program. This library enables C programs to use rope type. In the demonstration, we test the rope insert function in librope. It crashes when string fits into the character that causes corruption in UTF-8 is inserted with rope insert function. Now, let's take a look at the demonstration of Fuzz4B. The user invokes Fuzz4B by executing a Python program. AFL is CUI-based tool, so Fuzz4B provides its GUI for novices. This is the startup window of Fuzz4B. This window has three menus: Fuzzing, View, and Debug. The View menu is for choosing display formats. The user can start fuzzing by setting Start in the fuzzing menu. Before starting fuzzing, Fuzz4B asks the user to compile target program for AFL and then asks the user to select the target program and files for initialities. Through this interaction, even novices can invoke AFL and start fuzzing. During fuzzing, the user can confirm the windows of both AFL and Fuzz4B. Once AFL detects a failure, this table shows the path of the fuzz dynamically. The user can recognize at a glance that AFL detects some failures. If the user selects Stop in the fuzzing menu, Fuzz4B terminates the process of AFL. If the user selects the fuzz from this table, this upper two panels shows the fuzz that caused a crash and the fuzz in the queue of AFL. The user can confirm fuzzes in a single click. Then, items in the debug menu become enabled. If the user selects Run Program with Fuzz in debug menu, this dialog appears. The user can use the Pro Crash feature in this dialog. By selecting a fuzz, you drag to fit the target program and clicking this button. Fuzz4B invokes GDB and runs the target program in GDB with selected fuzz. Now, the user can reproduce failures without running complicated commands. If the user selects Reduce Fuzz and clicks Yes, Fuzz4B releases the Fuzz by GD feature. The lowest panel shows Reduced Fuzz. This Fuzz makes it easier for users to guess causal failures compared to original one. As a conclusion, in order to address AFL's hindrances, we propose Fuzz4B, which is a front end to AFL for novices. Fuzz4B also provides users the Pro Crash to reproduce failures and DD to reduce the size of fuzzes. Finally, we demonstrated the use of Fuzz4B to discover the failure of an open source library. For future works, we plan to realize a feature for decision support to determine when to stop a fuzzing campaign. Also, we plan to evaluate whether Fuzz4B is helpful for novices. Thank you.